Hey, in this video I'm going to use a queue to build a simulation of a checkout line at a store. The checkout line is a classic example of a queue because the first person in the checkout line is the first person who should get checked out. When you go into a store, there's a cashier or whatever you want to call the employee who's waiting for a customer to get in line. The customer gets in line, the cashier checks them out. That customer will have a random number of items in their basket or buggy here in Western Pennsylvania, and the cashier can only process so many items per minute. We're going to see what happens when we randomly simulate the number of customers that enter the cashier's queue, figure out how long the cashier takes to process each customer, and then after 2 hours, see how many customers the cashier has processed and how many items they've gone through and how long they spend per customer. This simulation is very illustrative in how you build complex business or scientific simulations. So let me take a look at my customer file that I've given you. Okay, so right now I've got this person set at 20 items per minute. That's not bad. The customer, when I generate the new customer, it'll randomly generate between 1 and 60 items in the basket. I'm set up so 25% of my customers use cash. Cash takes longer than credit cards to pay, so what I'm doing is I'm generating a number between 0 and 3, and if it's divisible by 4, which will only be 0, there'll be a cash. So roughly a quarter of my customers will use cash, and the rest will be credit card. I then calculate checkout time, and if payment time is cash, I'm going to count 2 minutes additional for that customer because I have to count the cash, get the change back. People are always fumbling through their wallets looking for quarters. If it's a credit card, it takes a minute. Now I do have a glitch here in this line. This line is everything integer. Let's cast this. I'll get a much better checkout time. My checkout time is how many items in the buggy divided by their items per minute. And I'm assuming that this cashier can do 20 items per minute. Now, I didn't just pull that out of my ear. I did actually look that up, and that's roughly what an average cashier can walk through. And I confirmed that with my daughter, who at one point was a cashier at Target, and she said, yeah, that's about right. So every time I create a new customer, it's automatically going to fill their buggy with random numbers, and it's going to randomly pick a payment method and calculate their check-in time. Now I know that this isn't a perfect simulation because it's completely random. But over time, when I generate multiple runs of this, it'll get pretty close to reality. All right, let's see how my customer works. So all over my main, I have standard pound includes. I've included my customer.h, and I've included q. Okay. So I'm going to just create a customer. See what I get. So my one random customer has 42 items in their buggy and they're using card. If I want to see that I do a lot of this, let's surround this with a for loop. Let's generate 10 customers. And 42, 35, 4, 30. They're the same numbers again because I have not yet seeded this. But you can see that each one of my customers has a different number of items in the buggy and different type of payment method. When I add an srand, these numbers should change. It won't have 42 as my first number each time. So 39, 52. And you can see that most of my people are cash. Here, 1 out of 10 is, or most people are car. 1 out of 10 is cash. One before was a little more closer to 25%. So it's random. So I have random customers. So I know that this works. I'm going to get rid of my for loop because I don't need it there. That was just a demonstration. So let's create our checkout line. So I created my checkout line of type customer. Now I keep talking about you can use these custom classes in your standard template library, and this is which you need to have defined. Less than, greater than. The ampersands are optional. You can go either way, it'll be happy. And I overloaded double less than just for my own friendliness. Equal equal also has to be defined. Okay, so I have my checkout line. Create some stat variables. I'm putting them globally because I'm going to pass them in and out of functions. It's easier. It's lazy, but it's easy. I'm also going to have a couple functions I need. Add customer is going to randomly add customers to the queue. Initially, it's going to add a customer a minute, which is insane. Over some time, I'm going to make it random so we get a different number of customers entering the queue. I'll do that right here. So basically just added a new customer to my queue. I forgot my parentheses. So this will call my customer constructor and add it to my queue. Checkout, when I write it, is going to take that checkout time and use that to determine whether or not the customer is still in the queue or has left the queue because they're done. I'll deal with that one later. I want to simulate what happens with my cashier over 2 hours of their day. So I'm going to do this with a for loop. Two hours is 120 minutes. 2 times 60. I have an extra equal there. Got a little stuttery. All right, so minutes equal 1, minutes less than or equal 20, minutes plus plus. Great. I'm going to add customer here. And then start putting my stats. Checkout line size is going to be how many people were left in the queue. Now, after I run this right now, I should have 120 people in my queue. I do. 120 people in the queue because I have not checked anybody out yet. If I call checkout, and if I have an extremely efficient cashier, who can process a customer per minute, she would never ever leave that job. 0 people left in line. Okay, so my structure works. Let's start adding some real logic to this. Okay, so I'm going to comment out this particular line. I'm going to comment out both those testing lines in my add and my checkout. So I know my logic's okay. Let's start with add customer. If you've been in a store, you know that sometimes there's a lot of people in line, sometimes there's nobody in line. Quite often the cashier is standing there waiting for someone to appear in their line. And I'm going to have to simulate that somehow in my add customer. So what I'm going to do is I'm going to generate a random number between 1 and 0 and 50, or 1 and 50, excuse me. And I'm going to use that to determine how many people are in the line. Now, most of the time, nobody's going to enter my line. That's just how it works, especially in retail today. You're at a Target 2 o'clock in the afternoon. There's like 4 people in the store, so nobody's in line. You at that same Target at 5 o'clock right after work. There's 50 people in the store and 10 of them are in line. So it's going to be kind of random. So I'm going to generate a random number. And this will generate between 0 and 49. The way that I'm building this up, smaller numbers indicate busier times. Okay? And I'm going to set it up also so that there is one way that 3 customers enter the line. There's going to be 2 ways that 2 customers enter the line. 4 ways that 1 customer enter the line. And the remainder, which is essentially 50 minus 1 plus 2 plus 4, which is 7. So we're going to have a not very busy store. And now if I want to change that again, this 50, this magic number that I just made up, if I make that smaller, you'll have more customers in line. If I make it bigger, I'll have fewer customers in line. And I'm going to handle this by using a simple switch. This is very similar, this logic I'm about to build, as to how the slot machines are generated. So I'm going to build my cases for 3 customers. I'm going to build a case. And I've chosen here. You can choose any number you want. Just pick one of them. So if I roll a 0, 3 customers enter my line. I'm going to break that. I'm going to use 2 possibilities for 2 customers. I'm going to use the pass down logic of cases. So if a 1 or 2 is generated, 2 customers are in line. If you want more than 2 objects, you can put as many cases in here as you want. The more cases you have, the more likely it is to appear. So again, if you think of a slot machine, we'll say the cherry is the most unlikely thing to happen. So it'll only roll up 1 time. Whereas the bust is the most likely thing to pop up. It'll happen more often with more cases. It's now for my 1 customer entering the line. And I can repeat this case as many times as I wish. If I don't roll 0, 1, 2, 3, 4, 5, or 6, no customers. All right, so I know this is a little weird, but again, it's very similar to how a lot of randomization is done when some things are more likely than others. So right now, it's most likely that 1 customer will enter the line because there are 4 ways that can happen. Right now, it's 4 out of 50. Let's do a quick run on what we get. Did I miss something? No, I just have everything highlighted. So after 2 hours, I've got 38 people in line. I run it again. 33 people in line. 43 people in line. All right, so it's working. In practice, I got between 25 and 35 as a pretty solid average. If you have more than 100, you forgot to comment this out. All right, so now let's deal with checking your customers. The checkout has to run only if the queue is not empty. So if the queue is empty, I'm not going to worry about checking customers out. So if it's not empty, check them out. You might see people putting the ampersand or the exclamation mark in front of it. That's perfectly valid, but that not symbol can be hard to read. So I find it more consistent and clear to equal false there. So if checkout line empty is false, run the checkouts. So now let's handle our checkout logic. So we're going to have a current customer. That's the person at the front of the line. I'm going to start using my variables I defined up here, including current customer time. And recall that when I generated my customer, I generated this checkout time, which is how many minutes I'm estimating it's going to take to check this customer out. So I'm going to use that with some logic. I'm going to keep calling checkout, and I'm going to add one to current customer time. Once current customer time is longer than it takes to check out the person, I'll pop the person out of line. So it adds a minute to the current customer time. So the current customer time is bigger than the current get checkout time. This now means the customer is paid for. Customer's down, we can pop them from the line. So I'm going to count that I just did a customer. I'm going to reset that time to be 0 because I'm done with that customer and now come back to a new customer. I'm going to total up the items sold. And this is all handled in my class, which is awesome. And I'll pop that customer out of the queue. All right, so let's go back up to main. Let's add a few more variables here. Let's see what happens. And let's see how long it takes me per customer. Stores are always worried about that. And so I get a float number. I'm going to divide this. Over 2 hours, if I take 2 hours divided by the number of customers, I get a rough estimate of time per customer. It's a pretty good estimate, actually. I could have also totaled up these numbers down here. So let's run this, see what we get. So after 2 hours, I had 2 people left over in line, 665 items sold, 22 customers have gone through my line, it means 24 have entered it, and it took me 5.5 minutes per customer. Not bad. Okay, so now let's run it again. And we see how dramatically different it is this time. That's a problem with random numbers, is they're all over the place. So we can't just deal with this running one time. We have to deal with this running multiple times. Yeah, so I'm going to start by doing this 10 times, then we'll kick it up to 15,000 times. We could also, if we wanted to, dump all this data out to an Excel file and do some stats later. But I'm not going to do that. You guys can pull it off. So let's make some modifications up here. So I'm going to set 10 runs here. I'm going to surround all of this with a for loop. Format this so we can all see what I did. So I surrounded the code you had in main, with the exception of the srand, with a for loop. And I'm going to comment them so I don't get lost. Let's just run this. I should get 10 of those outputs. And that's all great. Except you notice how the numbers get smaller as we go down. Time for customers 5 minutes, 2 minutes, 1 minute, 0 minutes, half a minute. The reason is whenever we start running these in batches and trials, I need to reset some variables. So I need to reset my items sold. Oops, I can type. Reset the number of customers I did. Basically, every variable I do in the stats I need to reset, and I also need to clear the queue. Because I'm not doing, 20 hours of consecutive customer satisfaction work. I'm doing 10 trials of 2. So basically, as long as the checkout line is empty, I'm going to pop it. So run this. Now the numbers are consistent. So we have 10 distinct runs. Okay, so eventually we're going to change this to 15,000, which means I don't want to see 15,000 repetitions of this. A, you can't look at it, and B, it'd take forever. You would do better to see out this in one line and dump it to a file and pull it up in Excel later. I'm going to comment this out, and I'm going to start doing some totaling and some averaging here. So let's create some new variables. Let's create a total for everything I care about. I'm going to total them up inside of this trial for loop before I zero them out. And then outside of the trial for loop, I'm going to dump out the averages. So down here, let's do some totaling. Again, before you zero them, or else you get a whole bunch of zeros. Alright, so I've got totals going on here, and again, that's inside my trials loop before I zero everything out. So I will have a total of each run. Now we just print it out. Outside of the trial loop, repeat something like this. I'm just going to copy this and modify it. If you're not sure how I did that quick, that was Control-KU to uncomment and Control-KC to comment. So I'm going to modify that first line after how many runs. And make sure we know that they're averages. So instead of checkout line.size, it's going to be total left in line divided by runs. And we know runs is not 0 because we set it to be 10. Likewise, items sold will be tot items sold divided by runs. Tot cust counts. Yeah. And then instead of cust count here, we tot cust count. I think I have something wrong. No, it's clean. So let's run this after 10 runs. So after 10, on average, one person left in line. On average, you sold 724 items. On average of 24, and that time per customer, so I knew something was wrong there. Yeah, something's wrong there. For quickness, let me look at my finished ones. Let's see what I did. Time. Try it again. Okay, there we go. That's about right. Okay, now to do 15,000. My time compressor is still wrong. I wonder what I did differently. Let me take my working code. Oh, yeah. Shouldn't divide by 120. Now it's clean. Talk cost time divided by runs. That was my problem. Just wasn't thinking. There we go. All right. We're good. Okay, if you wanted to change items here, like if you want to get more customers in line, kick this number down. We're going to have a lot more people left over. Because the smaller the number was in that customer, the more people got in line. Likewise, if you have the data of cashiers, and this cashier can do 40 items per minute, nobody's left in line. And you're saving everybody. That's over 15,000 runs. Slower cashier, more people left in line. Awesome. All right, this is a really complicated demonstration, but it used the queue to solve the problem. All right, thanks for watching. Good luck.